Today really is just to do a quick review of switchgear and circuit breaker performance monitoring. It's critical when you start looking at the medium and high voltage assets that most of the customers or most of our customers have. And typically what they would do is on an annual basis, they would perform what's known as protection testing or protection relay testing, where they look at the protection circuitry on the switchgear and they get in companies to test just the protection side. But from a MarTech point of view, we want to look at the overall condition of the whole system, the circuit breaker, and not just the protection. So today we're going to be talking about some of the technologies and new innovations related to circuit breaker performance monitoring specifically. Nolde, so if we look at what we're seeing with our customers and what they're doing from a condition monitoring point of view and not just protection relay testing point of view, maybe you can give some background as to what we're seeing in industry and what we're actually installing and supplying.
So currently, most of the condition monitoring that happens on our client sites is either annual parcel discharge assessments, where we look at the condition of the switchgear as a whole, looking at the cables, the switchgear itself, the internals of the switchgear when you come to the VTs and CTs, the bus sections and circuit breakers. That's basically the most that happens on site currently, and then where we're installing is basically what we're looking at permanent monitoring solutions for the switchgear as well in regards to parcel discharge, and that's basically what is currently happening in the market.
But what we are seeing from a more from a not from protection, but more from a circuit breaker performance monitoring point of view, the partial discharge systems that we install are looking at the overall system, and they look as to what's going to fail. But from a performance point of view, there's also certain critical aspects that you want to consider on your switchgear and on your circuit breakers. So for example, if you're running with SF6 switchgear, you're also going to want to start looking at the gas analysis. It's the same way that you do on a transformer. The gases in SF6 circuit breakers tell a story, and you can actually do the same type of analysis on your SF6 circuit breakers that you do on your oil-cooled transformers. So you're effectively looking to see if there's any moisture in the gases, you're looking to see if there's any impurities or if there's any byproducts that are produced due to discharge or arcing or overheating in the circuit breaker itself. And then also one of the main things with circuit breakers is you also want to look at the tap coil integrity and also the taps, because the circuit breaker is like a switch. And you want to make sure that those tap connections are in a good condition and you don't have any arcing or pitting or overheating on your taps, because those can lead to sticking contacts. Nolde, maybe you can comment on that as well.
Yeah, so in the past what we've seen on sticky contacts is that your breaker does not operate as it should. When it's supposed to open or close, especially with SF6, the SF6 gas has to form the insulation where your contacts need to open and close. So then as soon as you get a sticky switch inside, that tends to slow the operation of your breaker, or it doesn't operate at all. So you'll have a faulty breaker.
And what that means is that under a fault condition, it doesn't open, and then that can lead to an explosion or a fault further down the line on the connected equipment as well. So that's why that's one of the important aspects to look at. Some of the other aspects that we look at from a performance point of view is to look at the number of counts that the breaker is operated at, because normally from a maintenance point of view, you maintain your breaker based on the number of operations that it goes through during its life cycle. So it's the same as you looking at your car and you're looking at the number of kilometers that you do. You base your service on the number of kilometers that you do, and on the breakers, you're looking at the number of operations. And based on those operations, that'll determine how often you want to look to maintain and service your breaker. Some of the other aspects that we look at as well is looking at the, for example, on the larger breakers, we look at the cabinet enclosures. We're looking at the temperatures. We're looking at the ambient temperature of the breaker, the temperature on the contacts. We're also looking at, for example, on the SF6 side, we're looking at the temperature of the SF6 gas. And then also we are looking at the interrupter conditions, where we, for example, measure how long it takes for the breaker to actually open or close. Because over time, if the breaker is starting to age, that time difference that you see in the operation of the breaker becomes more and more important, because if it's taking longer and longer and longer to open or close, that means that you are starting to get more high energy electrical discharge or contact during the breaker opening and closing, which causes some issues and can lead to breaker failure. So it's not just to look at the protection side, it's really to look at the condition and the performance of your breaker as well. Noldo, have you got anything else that you want to add from a performance point of view? Maybe just the fact that some of the work that we do on the 132 kV SF6 gas insulated switchgear, we perform online PD measurements, but also looking at the overall system, and maybe Noldo can just comment on what we're seeing in industry related to gas insulated switchgear.
So when it comes to the gas insulated switchgear, you obviously need to use quite advanced equipment to get your overall health condition checked or your performance conditions checked. Where SF6 is normally a quite good insulation medium, there's always a possibility for something to go wrong. On GIS or SF6 applications, it's always important to make sure that you do not have any fault conditions, you don't have any leaks in the system, as it also is a quite big environmental hazard. But with the advanced equipment that we use in the market, you get a quite good understanding that what could go wrong if there's something that's brewing inside your system, and you could classify it and identify it quite quickly and then rather repair it before there's a failure. So using advanced technology, you can see possible discharge within the system. You can classify it to say if it's coming from the bus sections or coming from your breakers or your cable sections. So basically you can do quite a lot of assessments on those boards, and I would say it's quite important, because if you've got a failure on a 132 kV system, it leads to a major failure and also a big area outage.
And also the cost related to repairing that type of switchgear is very expensive. And I think one thing that Noldo did mention, the environmental impact related to SF6. SF6 is classified as one of the most dangerous gases when it comes to greenhouse heating effect. So you don't want any SF6 leaks coming from your SF6 switchgear. And that's also one of the things that we do monitor as well. So we monitor the SF6 pressures just to make sure that there aren't any leaks. Because if you do have those, there can be fines that are applicable to the amount of SF6 gas that is being released into the atmosphere from your switchgear. But if there's any other questions, please feel free to visit our website at www.martech.co.za or contact us directly.